Good morning, this is Dr. Sailaja working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today in this lecture, we are going to study about the testing of hypothesis for large samples. So in these large samples, we are giving the claim about the population parameter. Population parameter, we are taking it as mean. So testing of hypothesis for single mean. What is a single mean? Single mean is one sample data. Suppose we have taken one sample data from the population and we are giving the conclusion about the population parameter. Then that type is called testing of hypothesis for single mean. Single means only one sample data. So here we are studying about the large sample data. Large sample is n greater than 30. That means the sample consists of more than 30 or equal to 30 objects. Here we are testing about the mean of the population. For large samples, the test statistic is z-test. So the test statistic for large samples to study the population mean is x bar minus mu by sigma by root n. Here x bar is mean of the sample, mu is mean of the population, sigma is standard deviation of the population, n is size of the sample. Suppose here sigma is that is standard deviation of the population is not given, then we take the standard deviation of the sample and which is denoted by S. So the formula becomes x bar minus mu by S by root n. So depending on the given sample data, we take or we apply appropriate formula. Either x bar minus mu by sigma by root n if population standard deviation is given, or x bar minus mu by S by root n if sample standard deviation is given. Here sigma by root n is standard error of a sample mean. Standard error of a sample mean is denoted by SE of x bar, that is sigma by root n. So this formula can be written as x bar minus mu by standard error of x bar. Standard error of x bar. And the maximum error in our estimation is denoted by capital A and Z alpha by 2. This is a tabular value of Z into standard error of sample mean. So this is the maximum error in our estimation. And the confidence interval for mean. Here we are testing the hypothesis about the population mean mu equal to mu naught. So this is our claim and this is our hypothesis. Here this confidence interval is, this is our interval estimation about the population mean. That means population mean lies in which interval. So this is lower limit and this is upper limit. So this is the confidence interval mu population mean belongs to in the interval x bar minus E, comma x bar plus E, where E is the maximum error of our estimation or about in the population parameter, whatever we have given our claim. So mu belongs to in this interval. So these are the formulas to calculate Z value and the tabular value Z alpha by 2. So these tabular values for that These are the tabular values for Z. For 10%, two-tailed test. For 5%, two-tailed test. And 1%, two-tailed test. So we compare our calculated value, Z calculated value, with this tabular value. Based on the alternative hypothesis, how we define an alternative hypothesis, whether two-tailed test mu is greater than mu naught or mu less than mu naught. This is one-tailed test. Mu not equal to mu naught. This is two-tailed test. So based on this alternative hypothesis, we choose the appropriate tabular value for Z. So 5%, 1% and 10%, two-tailed, right-tailed, left-tailed. These are the tabular values. Now, when we are solving the problems, always we remember first whatever the data given in the question, we write the data in mathematical notations. The first step is write the given data in mathematical notation. Then we write the procedure for testing of hypothesis. So in testing of hypothesis, we have 5 steps: null hypothesis, alternative hypothesis, level of significance, test statistic, and conclusion. So these 5 steps should write, must and should write. And the last step is conclusion about the population parameter, whether you are accepting or rejecting. This conclusion based on calculated value and tabular value. We both compare these two values. If calculated value is less than tabular value, then we accept null hypothesis. If calculated value is greater than tabular value, then we reject null hypothesis at some percentage of error in our claim. So first question, according to the norms established for a mechanical aptitude test, persons who are 18-year-old have an average height of 73.2 with standard deviation of 8.6. If 45 randomly selected persons of that average height 76.7, test the null hypothesis mu equal to 73.2 against the alternative hypothesis mu greater than 73.2 at a 0.01 level of significance. So these are the main data in the given question. So here average or mean, both are same. So what is given? Population mean, here mu is population mean. Population mean is denoted by mu. So we write in mathematical form, that is mu equal to 73.2 and sample size, that is n equal to 45. Here n equal to 45 means which is greater than 30. Which is greater than 30 means this sample is large sample. So for large sample, and we are testing the population mean mu equal to 73.2. So here only one sample data is given. Only one sample is taken from the population, that is, and that sample consists of 45 randomly selected persons. And whose average height, that means the mean of the sample, these 45 persons mean height is given. So 45% mean height means that is the sample mean. So sample mean is denoted by x bar and which is given 76.7. And population standard deviation also given, that is with standard deviation of 8.6. Population standard deviation is denoted by sigma and which is equal to 8.6. So one sample data is given and a large sample data is given. Population mean is given. So mean standard deviation. Large sample data means we are testing the population mean for large samples. So this is the data. First step this is. Now coming to the second step, null hypothesis. So what is a null hypothesis? In this question we are testing the null hypothesis, that is he claimed that mu equal to 73.2. The population mean height of that person is 73.2. That we are testing. So that's why this is null hypothesis. That is his claim. The average height of the persons or population is mu equal to 73.2. Now whether we have to accept or reject this null hypothesis based on the sample data. Now here null hypothesis is defined or claimed as mu equal to 73.2, and alternative hypothesis we can define in three ways, whether mu greater than or mu less than or mu not equal. But it is also given in the question, that is take the alternative hypothesis as mu greater than 73.2. That means this is mu greater than 73.2 means one tail test, and moreover this is right tail test. Since greater than is there, that means here the total error is taken to the right of mean. So this is alpha, and this region is 1 minus alpha. So this is acceptance region and this is rejection region. So here we have taken the total error to the right of mean. So that's why this is right tail test. And this is greater than means only one tail test. So here what is the error in our claim? In our claim, that is the population mean height is 73.2. In this claim, what may be the error? So we take, there may be 1% error in our claim. So that is 1% means 0.01. So this error is 0.01. Now, null hypothesis is the first step. Alternative hypothesis is the second step in procedure of testing hypothesis. Third step is level of significance, which is denoted by alpha, and it is also given in the question, that is 0.01 means 1%. Now the fourth step is test statistic. Test statistic is based on the sample data. So sample data means here the mean and standard deviation data is given, and here we are testing about the population mean. So the formula is x bar minus mu by sigma by root n. This is the formula. For large samples, we always apply Z test only. So Z test, in this Z test also, mean standard deviation data is given and only one sample data is given. So that's why we apply the formula Z is equal to x bar minus mu by sigma by root n. Here sigma value is known. That means population standard deviation is given in the question. Population standard deviation is given. So that's why we take the formula sigma by root n. So after calculation, Z value is 2.73. Now Z calculated value is 2.73 by applying this formula. Now, what is the tabular value for right tail test? So, tabular value depending on level of significance and alternative hypothesis. In what way you have defined the alternative hypothesis? Whether two-tailed or one-tailed. In one-tailed also right-tailed or left-tailed. So, based on that, we write the tabular value for Z. So here alpha is 1% and right tailed. So see the tabular values. Right tailed 1%. Tabular value is Z alpha equal to 2.33. So this is In right-tailed, if alpha level is 1%, then tabular value for Z alpha is 2.33. So here we can take it as 2.33 is a tabular value and 2.73 is a calculated value. Now compare these two values. So Z calculated is less than Z tabular value. 2.73 is greater than 2.33. Therefore, at 1% level of significance, we reject the null hypothesis. So, Z calculated is greater than Z tabular value. We reject the null hypothesis H0 at a 1% level of significance. We have rejected. So, we rejected null hypothesis means we are accepting alternative hypothesis. What is that alternative hypothesis? Mu is greater than 73.2. So, this is rejected. Our claim mu equal to 73.2 is rejected based on this calculated value and tabular value. So, what is alternative hypothesis? Mu greater than 73.2. This we accepted. This is rejected means obviously this is accepted. See the next example. A sample of 400 items is taken from a population whose standard deviation is 10. The mean of the sample is 40. So 400 items, mean of the sample, and population whose standard deviation is 10. Test whether the sample has came from a population or not with mean 38. This population contains the mean 38. Also calculate 95% confidence interval for the population. So we write the first step, that is the data in mathematical notations. So what is given? So a sample of 400 items. So sample consists of 400 objects. So n is equal to 400. Sample size. Sample size is denoted by small n and which contains 400 items. So n is equal to 400 means greater than 30. Greater than 30 means large sample. Next, population standard deviation is 10. Population standard deviation denoted by sigma, which is equal to 10. And the mean of the sample is 40. Mean of the sample denoted by x bar. So x bar equal to 40. Next. And the population mean also claimed that is 38. He claimed that the population mean is 38. So the population mean is 38, and whether this 38, this sample is drawn from the same population or not, that we are testing. That means here we are claiming that the population mean mu equal to 38. This is our claim. Now, procedure. The first step, null hypothesis denoted by H0, claim about the population parameter. Here the parameter is mean of the population. Mean of the population is denoted by mu, which he claimed that 38. Mu equal to 38. Next, alternative hypothesis, which it is not given anything in the question. So, in general, we define the alternative hypothesis as mu not equal to 38. Not equal to means this is two-tailed test. That means the total error is divided into two equal parts on either side of the mean. So here the level of significance also calculate 95% confidence interval also we have to calculate. That means 95% is the confidence. Remaining 5% is the error. So error is denoted by alpha and which is 5%. 95% confidence is remaining 5% is the error. That is level of significance and which is denoted by alpha. Here we have defined the alternative hypothesis mu not equal to 38 is two-tailed test. So alpha by 2. Total error divided into two equal parts. So this is rejection region. This is acceptance region. 1 minus alpha. So level of significance is 5%, two-tailed. Now test statistic. Here what we are testing, whether to accept our null hypothesis or not. So what is null hypothesis? It is claimed that mu equal to 38. So we are testing population mean, and this is large sample. Mean, standard deviation data, and moreover one sample data is given. So that's why the appropriate test statistic is Z is equal to x bar minus mu by sigma by root n. So x bar, that is mean of the sample, is 40 minus claim, that is what is his claim? Mean of the population is 38. So this is 40 minus 38 by sigma is population standard deviation, that is also given 10 by size of the sample. N is equal to 400. So sigma by root n. So root 400. So after calculation, we get Z calculated value. Z calculated value is 4. Now we see the tabular value, that is based on alternative hypothesis and the level of significance. Alternative hypothesis is a two-tailed and the level of significance is 5%. See the tabular value. 5% two-tailed test. 5% two-tailed test is 1.96. So Z tabular value is 1.96. Z calculated value is 4. Now compare these two values. So calculated value is greater than Z tabular value. Therefore, we reject a null hypothesis at a 5% level of significance. So here we are rejecting null hypothesis means we are accepting alternative hypothesis. What is alternative hypothesis? Mu not equal to 38. Mu equal to 38 is rejected. So mu not equal to 38 is accepted. Mu not equal to 38 means maybe greater than 38 or less than 38. So that is depending on calculated value and tabular value. And also we have to calculate the confidence interval for population mean. And population mean mu belongs to in this interval. X bar minus E, comma x bar plus E. This is lower limit and this is upper limit. So in which interval the population mean belongs to. So here x bar is mean of the sample. Mean of the sample is 40, that is given in the question, and E is maximum error in our estimation. So that is Z alpha by 2. Z alpha by 2 means here two-tailed test. Z alpha by 2. So the two-tailed test value is 1.96. So two-tailed test tabular value we have to take here. Z tabular value for two-tailed test is 1.96 into sigma, that is a population standard deviation is 10 and sample size is 400. So Z alpha by 2 into sigma by root n value is 0.98. This is maximum error in our estimation or in our hypothesis. So x bar minus e is the lower limit, x bar plus e is the upper limit. So x bar is 40 and e is 0.98. So 40 minus 0.98, 40 plus 0.98. The lower limit is 39.02 and upper limit is 40.98. So the population mean mu belongs to in this interval 39.02 and 40.98. That means mu belongs to in this interval means mu should be greater than 39.02 and less than 40.98. But our claim is mu equal to 38. So that's why we rejected the null hypothesis. Another example, a sample of 900 members has a mean of 3.4 centimeters and standard deviation 2.61 centimeters. Is the sample from a large population of a mean 3.25 centimeter and standard deviation 2.61 centimeter. If the population is normal and its mean is unknown, find the 95% and 98% confidence interval. So first we write the given data in mathematical notations. So 900 members is taken from the population. So this is a sample. Sample size is n, denoted by n, and which is equal to 900. This is sample size, which is greater than 30. So that's why this is large sample. And also given that this sample mean is denoted by x bar and which is equal to 3.4 centimeter. X bar equal to 3.4 centimeter. And standard deviation is 2.61 centimeter. Sample standard deviation is denoted by S. S equal to 2.61 centimeter. And also given that population mean is 3.25. So population mean is denoted by mu and his claim is 3.25. And standard deviation also given, that is equal to sample standard deviation sigma equal to 2.61. So population standard deviation is denoted by sigma, sample standard deviation is denoted by S. These two values are equal. So S equal to sigma equal to 2.61. And here we are taking also calculate 95% and 98% confidence interval for population mean. So first we test the hypothesis whether to accept or reject our claim about the population mean, that is mu equal to 3.25. This is the claim about the population mean. And alternative hypothesis, by default we are defining it as two-tail test mu not equal to 3.25. Since in the question it is not mentioned or not given anything about the alternative hypothesis. So in general we define two-tail test, that is mu not equal to 3.25. And 95% confidence interval means remaining 5% is the error in our estimation about the population mean or error in our claim about the population mean. So alpha equal to 5% is the error. And here we are testing about the population mean. So for large sample. For large sample, we take or we apply Z test. So Z is equal to x bar minus mu by sigma by root n. Substitute the values x bar mean of the sample, mu mean of the population, what he claimed, that is 3.25, and sigma, that is population standard deviation or sample standard deviation, both are equal. So sigma is 2.61 by sample size, that is 900. So the calculated value is 1.72. Now, what is the tabular value? Here we have taken the level of significance alpha equal to 5% and alternative hypothesis is a two-tailed test. Based on these two, the tabular value is Z alpha by 2 equal to 1.96. Already we have seen in the tabular values that is 5% is the alpha level and two-tailed test is 1.96. So this is a tabular value 1.96 and this is a calculated value 1.72. Now calculated value is less than tabular value. 1.72 is less than 1.96. So calculated value is less than tabular value. Therefore, we accept null hypothesis. We accept null hypothesis at a 5% level of significance. That means in our claim there may be 5% error. Now we calculate what is the confidence interval for population mean. So in which interval population mean belongs to. So for 95% confidence interval, the formula is mu belongs to x bar minus e comma x bar plus e. X bar is mean of the sample, E is the maximum error in our estimation and E equal to Z alpha by 2 into sigma by root n. Substitute the values E equal to Z alpha by 2 into sigma by root n. So Z alpha by 2 is the tabular value 1.96 for two-tailed test of 5% level of significance into sigma is 2.61 by root 900. This is 0.17. So E value is 0.17 and X bar is 3.4, that is mean of the sample. So add and subtract. Then this is the lower limit. This is upper limit. So mu belongs to 3.23 and 3.57. So greater than 3.23 and less than 3.57. This is the interval estimation about the population mean. So 3.25 is our estimation. So that value belongs in this interval. 3.25 lies in this interval. So that's why we have accepted the null hypothesis H naught equal to 3.25. Similarly, we can find 98% confidence interval also. That means 2% error. Thank you.